I've had a couple of people ask me questions about circuit layout a little bit like this, where the question goes that are these three resistors that I've circled here connected in series? And so if they were connected in series, the question is, can we simplify this as a 2 kilo ohm resistor plus a 3 kilo ohm resistor plus a 3 kilo ohm resistor, as a series circuit simplification? And the answer is no. So we cannot. So these are actually not able to be simplified in this way. And the reason is that the extra branch, this 6 kilo ohm resistor over here, kind of gets in the way, and it stops it being a fully series connection that we can simplify. So in this diagram here, the 3 kilo ohm resistors, those ones are connected in series, and you can simplify those ones. That's no problem at all. But the problem is that once you've done that, you wind up with these two parallel branches. So I can actually redraw this circuit in a way that might make this a little bit clearer. So if I redraw this circuit, then it might be a little easier to kind of recognize what's going on here. So if I have my voltage source, that voltage source is connected through a 2 kilo ohm resistor, and then I have basically two branches. So I have one branch which has 3 kilo ohm resistors, two of them, so that's 3 kilo ohms and 3 kilo ohms, and then another branch which has a 6 kilo ohm resistor, and all of these branches come back together to a node which connects to the negative of the power supply. So you should be able to look at this new redrawn version and recognize this is the same circuit as the first one. And when you draw it like this, it should be a little bit clearer that the resistors which are in the resistors which are in series is only the 3 kilo ohm resistors here. And in fact, what we have then is that the 2 kilo ohm resistor is in series with that whole branch. So to simplify this, here's what the way that we would actually approach it. So what we have here, this network of resistors is actually 2 kilo ohms in series with this network. I'm just going to sort of write parentheses here to indicate this, this network, which consists of a 6 kilo ohm resistor that is in parallel with 3 kilo ohms, which is in series with 3 kilo ohms. And so kind of written as a mathematical equation, that would be the simplification of this resistor network. So I hope that one explains the meaning of resistors being in series. If they're in series, there can be no other sort of parallel branches that shortcut any portion of that series resistance. Now, another situation that might be perhaps not immediately obvious to you is if you have a pattern like this, and here these 8 kilo ohm resistors are in parallel. So even though they're drawn on opposite sides of the current source, these two resistors are actually in parallel. And again, if you would like to make it a little more obvious, you can actually redraw that circuit and make it a little bit more explicit. So redrawn, we have current source, and that current source node is connected to the node of two different resistors, and then the node at the bottom of those resistors is connected back to the bottom of our current source. And so kind of redrawn, the circuit has this shape, and then perhaps it looks a little bit more like the parallel resistors that you're used to seeing. However, yeah, you should recognize, even if they're drawn kind of at opposite ends of the circuit, they're in parallel because it's the same node at the top and the bottom that connects them. So you basically recognize that all of this region here is all the same node. And similarly at the bottom, all of this portion down here is also, all of that is the same node. So parallel just means that the heads of those resistors and the tails of those resistors are connected to the same node. And therefore you use the rules for parallel simplification of resistors.